Good afternoon, friends, my dear students. We are trying to take the project compression network, and in the previous lecture, I have taken the table and I have explained to you clearly how the delta C and delta T will come, and then how the cost slope. All those information, whatever that was there in the table, we have transferred here onto this network. And if I start again, all the cost to slopes, this is the cost to slope. So for each one with an arrow I have put the cost to slope, and in the bracket I have put the crash duration, and this one open one is called to be the normal duration. So once using this, following the rules, in order to crash, first one will be the total cost, that is coming direct cost, that is 38,000 when I added, and T0 was the total project time, that is 23 days. Now first step will be, first thing, it has to be a critical path, and there should be a crash potential available, and the cost to slope has to be minimum. These are the three things basically. So critical path was having 2000, 1000, 500. This was the path that was critical before in the first stage. So this was 2000, this was 1000, this was 500. So this is supposed to be the lowest cost to slope for E activity. What is the crash potential available? 14 minus 6. We have 8 days available. So what I have done in the first stage, I have crashed activity E by 5 days. I could have done more also, but the difference between this path and this path, if you take the durations here, it was only 5 days. So that is the reason why I have taken 5 days. So we need to check this also, the final timings. Then 5 times the cost has been increased. How much cost? 5 into 500, that is 2500 has been increased. 2500 added to 38,000, that is coming as 40,500 rupees after the step 1. And what was the, so C1 will become 40,500, and T1 will become from 23 days to minus 5, that will become 18 days. I hope this step is clear. Then going to the second one, second stage or second step we call. Here again you have to see the critical path, crash potential, and the cost to slope. These are the three things always you have to remember: critical path, cost potential, and crash potential, and cost to slope. These are the three C's. Always you have to check here. Now once we have done this 5 days, this path was already critical. Now this path has also become critical. That's what I have written. T1. After that, the limitation was, what was the limitation on this crashing? It was the other path becoming critical. That was the limitation. That's why we could not do more than 5 days. That is the reason. Other path also 1, 2, 3, 5. That is 1, 2, 3, 5. These all also become the critical path. Now going to the next step, if we follow the same way, again take the critical path. So there are two critical paths now. One path this way, one path this way. Then crash potential available with all. Cost to slope you have to check now. Cost to slope will be, suppose if you crash this is a common activity, I can crash by 2 days, but how much value will increase? 2000 rupees. Now among these 4 activities, if I have to consider crashing, then I need to take a combination of the cost to slopes that will remain minimum, or that will give minimum cost. So if you take this one, then you need to crash this one. This one will be 3000 and this will be 1000. So it will be, for one day if I crash, it will be 4000. If this I crash one day, it will be 2000. If I crash these two, this is 1200 plus 500, that will become 1700. So, or if I take C and D, 1200 plus 1000, it will become 2200. If I take this B and E, this one will become 3500. So which is, among all these, which is the minimum cost to slope? 500 plus 1200. So that will become 1700. 1700 becomes the minimum CP, cost to slope, minimum CS. So what I have to do, what is the crash potential? Now you have to see among this. Here we have 9 and 6 means 3 days. Here we have 8 and 3, 5 days. So how much you can crash now? So crash, this step you have to write clearly. Crash activities D and E by how many days? You can do only 3 days because here it is limitation is coming as crash potential. If it would have been 4 days, you could have done by 4 days. If it would have been 5 days for both, you could have done because already you have 5 days here. Here it is only 3 days. So you can crash only by 3 days. Otherwise the other path will become distorted. You should not do that. Now what is the CE2 will be now cost to 2 at the second step 40,500 plus 3 into 1700. Now what will be T2? T2 will become now, it was 18 days, so 18 minus 3, that will become 15 days. I hope this step is clear. So how much will be the cost now? 3 into 1700, 3 into 1700 plus 40,500. This one will become 45,600. This is the actual cost now that will incur when we have crashed this. Now what is the position now? Again you have to cut here and you have to make a 6 and 6, and this 18 will become 15. This becomes 15 days. This becomes 15, and what will be the here it will be, this has reduced by 3 days, so 6. This one, how many days we have reduced? 3 days. That means we still have 5, 3. This one will become from 8, it will become 5. This one will become from 9, it will become 6. That's what. Then what will happen? It will become, so this activity has completely exhausted now. E, you cannot reduce that now. Now again both the activities have become, both the paths are still critical. That means we have not distorted any path, because if you count from here, 6 plus 4 10, 10 plus 5 15, 6 plus 3 9, 9 plus 6 15. So it will become, both the paths will still remain critical, but the limitation was crash potential. That was the limitation. Crash potential, it could not be done. Then now go to the third step. Third step will be, I hope the second step is clear. If it is not clear, you can ask me. Now going to the third step now, again it has to be critical path, crash potential, cost to slope. So what you can do, this is over now, so remove this now, this one and this one 2200, this one plus this one 4000, and this one will be just 2000. So this one will become, this one 3200, 2200, this one and this one will become 4000, and this one is 2000. So what we can do, crash, which is the minimum combination of that 1000 plus 1200, it is 2200. You cannot do, this is exhausted, finish. This one, if you add this plus this only, you can take 3000, 1000, 4000. This one, if you crash, it is common, the two critical paths will not be distorted, so you can crash activity A. By how many days? Whatever be the number of days, it's 2 days, so you can reduce this by 4. So maximum you can do is by 2 days only. Why? Because limitation again same, crash potential. Now what will be the C3? C3 will be 45,600 plus 2 into 2000. That will be equal to 4000. So 49,600. I am adding 4,000 to 45,600. So it becomes 49,000. What will become T3? T3 will become 15 minus how many days? 2 days. So that will be equal to 13 days. So now we can reduce this 15 will become now 13. You have to write here also. Then going to the one more step. So what happened? This is exhausted, finish. Now what is left in the fourth stage? Again only this combination left now. So this plus this will become 4,000. This plus this will become 2,200. So what is the crash potential here? 2 days, and here it is only 1 day. So you cannot reduce this by 2 days, but you can reduce only by 1 day. So the fourth step will be, now we will remove this. Fourth step will be, now I will write here at the top. This will maybe probably this is the last step. Fourth step will be crash activities C and D. Crash activities C and D. C and D by how many days? You can crash only by 1 day. You cannot crash by 2 days. Though there is a crash potential available here is 2 days. The crash potential available here is 1 day. The combination you are taking is 1000 plus 1200. That is the minimum among the rest. So it will be reduced by 1 day. So this one will become 2. This one will become 4. This one will become 1 day has gone. So it becomes 12. So what will be the C3? C4. Cost 4 will be equal to 49,600 plus 1 into 1000 plus 1200, that is 2200. That will be equal to how much? 51,800. This is the total cost. This is 51, yeah, this is 800. Then T4 will become equal to how much it was? 13 days. 13 minus 1, that will become 12 days now. And what is the limitation? Crash potential was the limitation again. So this one has become 2. This is also exhausted. This is not exhausted, still you have 1 day. This is not exhausted, still you have 1 day. But now if you are trying to go to fifth step, step 5, if you check the network, this is finished, this is finished, this is finished, this is not finished, this is not finished. But where is the combination? Combination of these two if you take and reduce by 1 day, this path will become distorted. So that is the reason why I said that the problem itself will give you the number of steps. Now no more crashing can be done. Finished. The network solution will be finished here. Why? Because you cannot reduce. You can reduce this. You cannot reduce this by 1 day. You cannot reduce this by 1 day because you don't have any other activity, parallel activity to that. Because this is finished. This is finished. This is finished. So what is the final duration you can get? This project can be done from how much days it was? Initially it was 23 days. Initially it was 23 days. Now you can complete this project in 12 days by paying this much amount above 38,000. That means 38,000 minus this amount, you will get the difference amount. So that amount will incur more to crash this particular project and complete this. How many days? 23 minus 12 means almost 11 days. So you are reducing this project by 11 days and you are just incurring this much cost above 38,000. If you subtract it from that, only the difference of cost you have to spend and 11 days you will save for the project. That is exactly what crashing says. If this has to be learnt in a proper way, because this is used everywhere in the field by all the consultants, by all the contractors. So I request you all to go through, read once again, go through that one and then try to find this. After that, how the problem ends and how optimum cost and optimum duration for this project we get, that I will show you in the next class by taking the example, same example, and trying to draw the graph. I hope this is clear. If it is not clear, please try to get me into touch and then DM me, whatever. Thank you very much.